Yeah, we can start our class today. So today we'll talk about something called PV, PV, and something called PVC. So you can hear my voice, right? No issues. Can you?
Yes, we can hear you.
Cool. So let's see when we are doing or working on Docker. I told something about volumes, right? So we create our own volumes, and we they are independent from the container life. So even though containers are deleted, so they'll be there. I mean, the data will be present, whatever data it is present inside the volume, and we can still mount the volume to another containers, and we can able to use it. So it's like preserving, I mean, persisting the data. The data won't be deleted along with the container. So similarly here also, I mean, what is there in the Kubernetes? I mean, I want a similar kind of thing in Kubernetes because here we create pods, right? Obviously, pods will delete. If the scaling happens, scale down happens, pods will delete eventually. So the data also will be gone. That's same thing, right? The data is deleting. So I want to preserve the data. So what you do at that time? So to overcome that, in Kubernetes we have a topic called PV, persistent volumes. PVC that I'll explain later, but PV is the concept for storage. Simple like what we did in Docker, like just exactly like try to remember that topic, whatever we discussed. We create our own volumes, we mount them, and we use host volumes and we mount them. Same thing. But here, this PV, whatever the concept we are will be seeing, will gives us more advantages than the Docker volumes because this PV we can if we are in a cloud, let's say environment, we can use the cloud volumes, cloud storages also in here. So that is also possible. But with Docker, it's just local volumes. I mean, locally only, local machine or let's say Swarm cluster within that only, but not outside that. But here directly we can talk to outside any volumes are there, any storage is there, so we can able to use them in our pods. So there are two concepts. One is PV, obviously, persistent volumes. Another is PVC, persistent volume claims. So here the idea is like we create a PV out of our hard disk. So let's say we have a disk maybe in some server. I mean, in our cluster somewhere, maybe a 10 GB disk. We can't use that directly. We can't use that in Kubernetes. We can't use that. So we have to create a PV out of that disk in order to use it. Just give me a minute. Just give me a minute. Yeah, I think we are continuing. So yeah, I was talking about the volumes. So we'll be creating a PV out of the disk. I mean, whatever storage we have. So we'll be creating a PV out of it because we can't use it directly. If you see here the image, you can admin, whoever the admin means, whoever managing the Kubernetes cluster, he's created PV out of where it can be AWS, it can be GCP or Azure volume storages, I mean, or your local storage also, or it can be any network storages like NFS, in anything that also, anywhere. So he create a PV, I mean, persistent volume out of it, and we want to use it, right? So in order to use it, we need to use persistent volume claim. We need to create a persistent volume claim. So what is PV? Okay, you got it. Okay, we'll create a PV out of our disk in order to use for Kubernetes. Okay, that is good. Then what is PVC? PVC shortcut, persistent volume claim. Still, even after creating a PV, pods cannot access it. I mean, at the cluster level, Kubernetes cluster level, Kubernetes know that, okay, API server knows it, okay, there is a PV or my volume is there, anything can be used. I mean, pods can use this. So in order to use by the pods, you have to create a PVC. That's why you're seeing here pods. So there is one more thing about this PVC. So let's say we created a PV of 10 GB. So now we may not need 10 GB now. Out of 10 GB, we just need maybe 5 GB or 1 GB, let's say. We create a volume claim, I mean PVC, for that specific storage based on our requirement out of the PV, out of the PV. So do you remember the concept of LVM in Linux? Do you remember it? I think we have discussed it. I'm not sure. May have definitely. So we create a PV, we create a VG, we create a LV. Like PV, there are also physical volume, that is, I mean, forget about that. So we create a volume out of the disk, I mean, storage, whatever we have. Out of that, we just create, use it what we need. I mean, out of 10 GB, let's say PV, you just use only 5 GB. Maybe later you may need it, but for now, you just need 5 GB. That 5 GB, you claim the storage. You're claiming it. There is a storage available. You claiming it out of that, or you claiming fully anything. So you use that storage into your pods by using PVC. So what we have to do is we have to create a PV first, obviously from the disk, and a PVC to claim the storage from the PV, because directly we cannot access the disk. That's why we created a PV. And from PVC, we use the PVC in our pod manifest files configurations everywhere, so that we can able to write the data into the disk, into the disk. So this is the structure. I mean, like how it will be like. Let me open Notepad. Let me write it maybe. So first, disk. Let's say local disk as an example. Local disk is there. Disk 10 GB storage as an example. I'll be creating persistent volume from the disk 10 GB as an example. I'm just taking 10 GB. So with this, cluster knows it. Cluster knows there is a storage. Now from this, I'll create claim. So out of this, taking some or P. So whatever PV we created here, 10 GB, we are claiming it. We are taking some out of it or full, I mean anything, and using it in the pods. So what happens is because this PV we created, okay, you may ask like, okay, we have local disk, we created a PV. It means cluster knows it. Can't we use it directly? This PV in the configuration so that pods can use it? That is not possible. That's why we have something called persistent volume claim. We have to use this in order to get the storage from the PV and use in the pod. This PVC pod will use the PVC to as a to store the data obviously. So how will pod use it as a volume? It's as a volume mounts we usually generally mount, right? So like that generally happens. So this is how the structure will be. So what we have to do is, I mean, there is a configuration inside it. We'll start with that, once we write the manifest file. So, but this is general idea of PV, PVC. PV is for just a piece of storage which is available where will be creating a PV to take the storage, to use in the cluster. PVC is like we are claiming some storage from the PV so that we can be used in the pods. So that PVC can be used in the pods, so that pod can store the data in that PVC. So if you let's say pod is storing the data, so where it will store now? So what happens is pod is using PVC, right? Correct. So now if pod store the data, it will go to PVC. But where is the PVC is coming from? here, PV, right? So if you store anything, any in the PVC, in the volume mount, wherever you mounted, the data will be present in persistent volume here. So it will be present here. Got it? So now what we have to do is we have to create a PV first, create a volume and use in our pod configuration. So before going into example, any doubts in PV, I mean just a description, I mean, at least an idea about what are those. Anything?
No.
So let's go and let's try. So first we have to create a PVC, right? Obviously. Sorry, first PV we have to create. My mistake, my mistake. So let's log in into the cluster. Master again, obviously. Qtl get pods, sorry, get nodes. Cool, they are ready. Let's try top nodes. See, auto scaling also ready. Cool. I'm just dealing with deployment. We'll create again. Don't worry. Cool. Now all are deleted. Let's delete the HPA also since we are not testing it because servers are too resources are too low. So all we have to do is create a PV. Let's go to YAML lint. So API version, obviously, kind we have to define, metadata we have to define. These three are common. API version, PV is a part of V1, kind, persistent, volume, metadata, name, test PV. I mean persistent volume. So I think it's fine. I'll create maybe in test namespace. Yeah, namespace, test namespace, obviously. Now this will change the spec we have to write. For everything spec will be there. Spec will be obviously depends on what kind that this will change. Now my requirement is uh, I have my local path. Mm, let's create a folder then. Slash opt mkdir test one something. I don't have permission. That's okay. Mkdir test volume something. cd test. So this path I want to mount. Since we don't have AWS, we can't try all those. So since we have local, I'll explain how to do this also. But I just for now, first example is I want to try this local volume. Let's keep it for now like that. So in the spec, first is capacity. Sorry, capacity. Now inside we have to define storage. How much storage you are creating a PV? How much storage available? 60 GB available. It's okay. Maybe 2 GB, 3 GB is enough for me because of less resources. Maybe 3 GB. I'm creating a PV for 3 GB out of whatever the disk is there, 16 GB. You can use full also, no problem. There is nothing wrong. So you can use it. Now, after storage, there is something called access modes. What is this access mode? It means you control how this should be accessible, how this PV should be accessible. There are three things: read, write once. That is one thing. Let me write here. Access modes are three are there. Read, write one, read, write many, read only there is X many. So here what's happening is right. See, we have clusters right in the sorry, we have servers right in the cluster. With this access modes, we are controlling how this PV need to be accessible. There might be a scenario that I want this PV, I mean whatever the volume we are creating, should be used by only one node at a time. If let's say there is a pod running using this PV, I mean the PVC, whatever we created, only one should be use this PV at a time, not two. Not two means not two nodes, obviously, not two pods. So at the time I'll use read write once, RWO. If I want to, let's say, read write multiple nodes, I mean one or more than two pods like this, you can go for read write many. If you want to go for read only many means multiple can be used this part, but only for read only. I mean, just read. They can't write the data. The pods cannot write the data. So you can use any of this. Like, let me write it here. The full form. Read, write, one means only one can use this at a time. One pod can use it at a time. Read, write, sorry, many. So multiple mods can be used this at a time. They can able to write it. Read only many. So multiple pods nodes can access this, but only read. They can't write to the disk. I mean, they can't store anything to the disk. So for our case, so we'll use read write many because we may have multiple parts, right? Read write many. See the spelling, capital, everything. So that's how the access moves. So now there is one more thing called persistent volume reclaim policy. This is a persistent volume reclaim policy. Sorry. So similarly, there are three types for reclaim policies. Sorry. So one is retain, another is delete, another is recycle. Sorry, recycle is gone, so forget about it. It's no more work. So two are there. First is retain. What is the retain is? See what I told. We need to create a PV first, and we need to create a PVC. Correct? Because they two link each other, and we can use the PVC in the pod. So within the PVC will fetch the storage from PV. That's the link. Retain means, let's say by default, I deleted the PVC because it's not required for me. I deleted it. So what happened to the data now? Data should be deleted or data should be kept. I want to data to be deleted if the PV is deleted, PVC is deleted. So the time you use the reclaim policy as delete. So the data will be deleted along with when the PVC is deleted. Retain means the data will be preserved. Data will be retained. I mean, so the volume will be retained even after the PVC is deleted. This one PVC is deleted. So you can use the same thing for multiple volumes. So we go for retain. Capital R, I guess. Yes. Yeah, I think we should correct. So these are the very basic things we have. Not basic things. Mostly this will be only. So there will be one extra thing that I'll tell you in some time. Okay. So these are all. I mean, still one more thing is there. I told everything. Correct. I told okay, capacity take 3 GB. Access modes read write many. I told okay, multiple pods can use this and they can write the data. Okay, that is also fine. Reclaim policy also I told. So if the PVC is deleted, still you can retain the data so that the other PVCs can use this if they want. I told everything here except regarding this path, right? I want to mount this path only in the pods. Apart from this, set out everything. So now this is the last thing. Sorry. Host path path in the quotes, obviously. You have to give in the quotes. This is the manifest file for PV. Is it clear? Any doubts in
Yeah.
that? Now simply just copy paste it. I mean, this path will be used as a volume, obviously. So you know that. You already all seen this in Docker. Let's create a file. Awesome. Let it come. Um, so let's log in back. So I'm just creating a file, pasting it. If you observe now, it will throw an error. Let's see. kubectl apply -spv dot c. There is persistent volume reclaim policy. Expected this. Let me open it. Reclaim policy is not there. PRSISTENT. Spelling is correct. Okay. Reclaim policy. Okay. This should be fine. I think version need to be changed. Let's go to official document. PV. If you don't find an example, just they'll give an example by default here. Let's go to manifest file v1, obviously. Sorry, this is part. Sorry. Here is the PVC. This is claim. Yeah, this is blah blah. This is fine. This is not. See, persistent volume reclaim policy. Same thing we are using that. Why? hmm What happened? Remaining observe. This is NFS thing. I'll tell you what is this, but small p, small p, small p. See, always observe these things. Capital letter, small letters. Now it should work. It's created. kubectl get PV. See, PV is here, ready. Status available. I mean, it's ready to be used. I mean, if you observe in the manifest file, I created in the namespace test, right? But I didn't use -n test, nothing like that. Even that is showing for me. Wow, because this namespace concept does not work in this one because PV does not have any namespace. It's available to the whole cluster level. See, unchanged means namespace. It did not took the namespace value which we gave because it's cluster level. This is what we gave, right? Now what we have to do is we have to create a PVC. Similar example you can see here, or we can write from scratch. Let's copy from here. Let's change to our scenario. It's okay. We better write, from scratch. Let's. But for PVC, we need a. I think CLA. Yeah. So this I still kept namespace because for volume claim we need a namespace. Obviously, it should be created in namespace because Our application is in test namespace. So PVC has to be in the test namespace, otherwise it won't work. So this PVC will try to go for a check for a PV. Is there a PV available or not? And it will try to talk to each other, and they'll bound together. They'll be like a sync. How they will work? Let's see now. Spec, this access modes. Sorry, read, write, many. With this access modes, will be it will talk. Let me write it fully. And of course, the resources. So what is the use of this PVC? We are claiming some storage out of the PV, and we are using it in the pods. So same thing we are doing here. So what we are doing is like we are creating a PVC and we are claiming 1 GB storage. What is the PV storage? I guess 3 GB. Yeah, see 3 GB. Out of this, we are claiming 1 GB storage. But how do this know to take it from this PV only? Based on the access modes. Based on the access modes. You may get a doubt. What if there are multiple PVs with the same access mode? How then it will take? That we'll see later. For now, it will take based on the access modes. Now let's create a PVC. Hope it's clear. We are just requesting 1 GB out of 3 GB from a PV. We did not mention the PV name anywhere. Let's see whether it will work or not. PVC.yml, copy, kubectl, apply -f PVC dot required value. Might be spelling. Storage I gave. No one said anything. Instead of storage, you have to say these things. And wait, the indentation also wrong. Like this. How do I know indentation is wrong? Because I'm see fourth letter I'm keeping everywhere. So I should follow that. Created kubectl get PVC. So I told you right. Namespace is mandatory for PVC, not for PV. And if you see it says PVC bound. What is volume test PV? Where is the test PV here? See? Test PV. It's linked to this one, bounded to this PV. Now you check the status of the PV. Bound. So this is linked to this. This PV, sorry, PVC got linked to PV. How it got linked? Based on the access modes. Let's delete the PVC. I deleted it. Check the PV status. Released. It means it's not bounded to anything now. Soon it will come available. So now let's change this to read write 1. Let's see. See pending. Why? It could not find anything because the access modes did not match. Now what you do? The access mode should be matched. Read write many has to be there. Blah 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 blah. Apply. Sorry, we can't change it. We have to delete and reapply. Delete PVC. I deleted it. Obviously correct. Apply. Created. See, it's bounded. It will take time. Normal, that is. What did I change? Haven't I changed it? Okay, retype many. It is still stuck. It will take some time. We can't wait that much time. Let's delete created both. Yeah, nothing is there. Now let's create kubectl apply PV dot. First we have to create a PV, obviously. Next PVC. It's bounded. It takes some time, but it'll work. Don't worry. If you observe there, PV we gave 3 GB storage, correct? And we claimed some storage, obviously here with 1 GB storage. So now you can use this PVC in the pod configuration so that this can be data can be stored. I mean, so now what we have to do is update our configuration. I mean, in the manifest file. So to use this, sorry, to use the PVC, and this PVC we can use only after status is bound. It should bound to any of the PV. Otherwise, it will be in a pending state, obviously. So now maybe test namespace, right? We created a PVC in test namespace, so we have to use test namespace only. I believe test namespace is this one, yes. Namespace is test. Now, where to use this? Go to any container. Let's say in test container, I want to mount it. After the ports, it's fine. Or after the image also, it is anything anywhere. I mean, after the containers, you can keep it anywhere. First thing is volume mounts. You have to define volume mounts. It means where you want to mount it. Mount path. Where you want to mount it means inside the pod, obviously. Mount path maybe slash opt slash test as an example. I'm just giving some random. What is the name? You can give any here. Local path something. Any name here. I'll tell you what is the name, importance of this name. So this is one. This is where we have to define where to mount it. Next is what to mount. We have the PVC, right? PVC has to be mounted. That we have to write. What to write? Is it, yeah, is it containers like this? Volumes. Name. The name has to be used same as here. Next, what you are mounting? Persistent volume claim. CL, sorry, I'm writing the spelling wrong continuously. And what is the claim name? Test PVC, if I believe. This is done. So like this, we have to use it. Now,
Spell check on claim name.
got it. Cool. Thank you. Claim name. I think it should be correct now. So now this is the volume we are mounting and where we are mounting. In the volume section, I defined a name. This is what a persistent claim name, the claim name I want to mount. And where within the pod, so mount part is this. And observe here, I am using the same name. I have to use the same name. Why? Because let's say, see, one volume is fine. I may mount multiple volumes in the same container, right? Then what I do, I'll define multiple volume mounts, multiple volumes in order to mount it. How this volume claim knows where to mount based on the name only. So what it will do is here volume claim check for the name local path is in any volume mounts is using the same name. If the name is matching, it will mount the claim in that path. If the name is not matching, it won't mount. It will throw error. Nothing to mount. I mean that's like. So now this is what uh, we are mounting about PVC. How we are mounting it. And if you observe, we have two containers, but I'm mounting only in Nginx container. I'm skipping into the Tomcat. We'll verify that once we log into container. Is it clear? We create a PVC, sorry, PV, taking, so by out of the volume, sorry, whatever the disk we have, We create a storage out of that, and uh, we'll create a PVC to claim some storage out of the PV, and the PVC will be used in the manifest file, pod manifest file, in the pod configuration, or to keep it simple, in the pod spec, pod specifications. Now apply it. Apply hyphen F, deploy. Error. Line 38 did not find the expected key. Go to line 38. Is there something wrong here? No, it's not line 38 somewhere. What is added? These are the things added. Volume mounts. Okay, mount path. Name. Correct. Volumes. Name. Persistent volume claim. Claim name. This is correct. Somewhere we gave something wrong. Let's see. Let's validate. Is it small? Okay, well, we should be small of this, correct? M should be small name. Hmm, somewhere. Let me check. Hmm, this is disturbing whatever the volumes we have added. Maybe we'll do one thing. We'll add the ports on top. Let's delete here. We'll add the ports on top. So let's go to images, ports, 80. Let's try. Hopefully it should work. Still same. So now 38. This is some syntax is wrong. I believe some syntax.
Yeah, actually, ports and resources should be in container level, right?
Sorry,
Resources also should be in container level, right?
I didn't get it.
Under volume.
Yeah, this has to be changed. I believe this has to be changed. This is wrong. So let me just change the syntax a little. What I think is it is thinking as another volume because see the volume section is inside the volume. This section looks like inside the volume. First, let me remove the Tomcat container. Let's see. We can add it later, no problem. One syntax error is save it. Version converted should be putting another version on and claim resources. What the hell is happening here? Did I give correct? Let me just wait. Wait, let me move it a little. See, the resources is wrong. Let me remove the resources also. We can add later, no problem. The syntax are confused a little bit. Let's try this. Indicator hyphen 927. What the hell? Volume, okay, hyphen name. The name is there. Persistent volume claim. Test PVC. Let's try. Did not find expect.
Volume should be under spec actually,
No.
not
This
we
should be
have.
correct. This is correct. We can try the same, but it won't work. Let's try. Let's try that. See, decoding error. Let's see here. Example maybe here. We have pod examples, I believe, somewhere. Come on, move it. Yeah. Volume C. Volume should be as containers. Volume mounts should be inside like this. See, I told you right. But why it is wrong? Let's compare our containers. Obviously, this is correct. We didn't change anything here. Blah 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 blah. It's fine. Volume mount. See, it is same as image below. So we have the volume mounts. Image. Volume should be right below the container. See the section.
No, in our case, it is nested, right, inside
What is that?
container. No, no, previously we kept inside the containers, right, the
Let's
volumes.
try. Let's try now. No worries. Let's try what it will happen. Okay. Now it should. It's created. See. The issue is we have other syntax, right? Like another Tomcat container is there and request and limits are there. Those has to be also modified according to this volume claim. So the syntax error is not this one. We have to just modify our indentation. But that's okay. That's okay. You can figure it out. kubectl get po hyphen n test I guess. What? Didn't we applied? Deployment applied. Let's try. Might be pod is not running. kubectl See, observe here the container, whatever the data. But scale up to replica to set to 3. Why it is failed to create? Let's try. Parts are not created. There is some issue. Can creating parts forbidden? Oh, see. Do you remember why this is happening? Any of you remember? Any of you identify the issue? You remember in the while working on namespaces, we were discussed quotas, namespace quotas. Remember? Request. I mean, we defined the namespace quota like pod should be this many, memory should be this many, CPU should be this many like this.
Yeah, resource limits, right?
Yes, not resource limits. I mean resource limits for the namespaces, the quotas. Let me show. See the resource quota for namespaces, correct? Now this is throwing error that hey, you told to restrict this, but you didn't define any request and limits in the container level. Without the request and limits, we cannot deploy because the resource quotas available at the namespace level. So we must have to define the resource quotas here. I mean request and limits. Otherwise, it won't work. So we can maybe place on top of like this. I don't remember what was earlier, but let's try request. Sorry, first thing is resources. Resources. Request CPU 100M, or you can keep it 1. Memory 70 MB maximum, I think. This is more than enough. Limits. CPU 200M. Memory 100. This is also maximum limit. It's fine. See, now it should work. kubectl apply -f deploy created. See, sorry, we need to check the ports. See, that's the error. It's telling us, hey, for your namespace, for your test namespace, we have set the limit quota, I mean resource quota limitation, correct? But you're not using those limitations in your I mean, deployment configuration. How do I figure out whether the limit is crossed or not if you don't set the limit? How do you know that? That's why when you're using limit request quotas, I mean the limit, I mean request quotas for namespace, you should use requests and limits in the manifest file. So like this, obviously, correct? So you might have seen the troubleshooting steps what I did. I mean, I didn't do anything. Just I checked the parts. There are no parts. I checked the deployments. Deployments also nothing, no errors. But we know that internally deployment creates a replica set. That replica set will create the pods. So I just came directly to replica set and describe it. You can see the error here. The kind of debugging steps I'm just trying to explain to you. So pods are running. Let's go to one pod. Kubectl ec-it pod slash maybe this one, anything. Copy, paste, -n test slash bin slash sh kubectl df -h slash opt slash test. Okay. Oh, this is the overall disk. That's one. But see, if I create, let's go to slash opt slash test, create something, touch, blah blah blah, something, whatever it is. Ls, it's created. See, now what happens is, if I go to this home Ubuntu, right? That's the path we just mounted, correct? Is this the one? Sorry, test volume is the one. Test volume. My bad, my bad. Data didn't came. Is this the one we mounted? Let me just see. Home Ubuntu test volume. It should come. That's okay. Let's wait. So, sorry, what I was. Yeah, that's about. It will come. Data will come. Don't worry. It will just take some time, but that's how you use PVPVC. I know it's a little bit of confusing, right? But it's pretty straightforward. We just create a PV. Out of that, we'll create a PVC, and that PVC we'll use in the pods. But of course, while creating a PV, there are something called reclaim policies, access modes. Based on that, we'll be doing it. And based on access modes only, the PVC will be bound to, I mean, sync to the PV. So, is this clear so far what I told?
Can we create same access mode of PV multiple?
Yes, you can create. Let's try that now. So we have,
Yeah.
let me try that.
So in that case, so we specify different mount part in the PV. So when we create a PVC with similar access mode, but we are not defining, right? We should be like tagged with this particular PV like
As
that.
as I told earlier, that will come now. I haven't discussed that yet. That will come, don't worry. So let's say I'm just creating one more PVC, same access modes. Maybe different names, see, that's it. Let's try kubectl apply sorry, test PVC1 storage again, sorry, no, storage spelling. It's created kubectl. It's pending. It will be continually pending because for one PV, only one PVC can bound, not two. If I delete this PV now, this will get bound, obviously. So one PV and one PVC only, not two. I mean, I didn't clear your doubt yet, but this is general I'm telling. So when you create a PV and immediately you created a PVC with the same access mode, no matter what it is, no what PVC it will get bound to it based on the access modes. But if you try to create another PVC with the same access modes, it will be in a pending state because the read write mode is already there. It's already bounded, so it can't bound. Now what it is waiting for is it's waiting for another PV to be created with the same access modes. So once we create a PV, immediately it will get bounded. Let's try that also. Same thing I'll do. Maybe except the names I'll change. Some random thing I'll simply paste. Everything. Test the PV1 I'll keep it. 3 GB, okay. Read write many, okay. Host path, I did not copy it. Let me just see the syntax how it is. Path column, yeah. Maybe slash home slash ubuntu slash test. Let's try to create this PV. Created. It's pending kubectl get PV available. So now this will be bound to this, but obviously PV has to be created first. That's how. Otherwise it won't work. So only one PVC and see it worked. Only one PVC to one PV. Only one, not two. So that's how. If you want to delete, simply delete. Maybe I'll delete first PVC. Test PV. What? Sorry, hyphen here. Now once it is done, 1P, it is also clear. So is it clear? Still, I haven't told that, but I just want to show you that one PV and one PVC can communicate together, not more than that. I mean, another PVC, another PV, not one PV but multiple PVCs, not one PVC but multiple PVs. That is not possible. So now, is it clear? I mean, so far, I mean, let's go to, there is one more topic as well. Same topic, I mean, not just one more topic. So,
Yeah.
if it is clear, there is one more thing called storage class. Let's go here. So you see in PV, PVC. Okay, they are working together. I'm using the volume. Let's say this PV, I mean, whatever we have just seen, creating a PV, we are creating it manually. And volume claim also, we are creating manually, obviously. So let's say my size is done, 10 GB is done, or volume claim 3 GB, I think 1 GB, let's say. They are done. We'll be increasing it manually, obviously. That's what we're doing. Let's say I don't want to create the PV manually because obviously 10 GB is full. I need to add 10 more GB. So it's manual work, right? I want to make it automatic. It means I want to create the PV automatically. So at that time, we'll be using this storage class. So to make it automatic. As of now, we've seen static volumes, static volume provisioning. So static, I mean manually, we'll be doing everything. I want to make it dynamic. Means simply what I do is, I mean, as of now, what we did is created a PV manually, created a PVC, and using it. Now PV size is full. I mean, 10 GB is full. Now I'll increase to 20 GB. Now obviously it's manual, right? I don't want like that. If let's say 20 GB is full, it should automatically increase the size to 30 or 40 or 50, whatever it is. That's called dynamic provisioning. Automatically, PV should be created and PV should be updated. So that will be achieved by using storage class. What do you mean? How it will create the PV? It means how do internally it's creating the volume. How it will create? In general environments, it won't work. Only in the cloud environments, this will work. I mean, when your cluster is running on a cloud integrated with the cloud systems, cloud services, then it will work. So all you have to do is create a storage class. Same thing, API version, storage class. I'll tell you a sample thing here. I think it should be in the documentation. Sorry, my I don't know why. Sorry, my throat is not good today. Storage class. See, you can define a storage class here. Let's go to another example. Done. No example. Idiots. Let's. Sorry. Yeah, storage class separately. Here. See, this is the storage class example. So what happens is, of course, this you know this already. So this provisioner reclaim policy, you know this already. Provisioner mount options, volume bind. So these things which will be required for the storage class. Let's say I'm in AWS cloud. AWS have storage types. There are one of the kind we I mean we don't know yet. We haven't discussed. But AWS have storage obviously. So when we use the storage class and we have to define the provisioner here, there will be a provisioner name for that. Let's say AWS dot something, some name will be there. So you have to provisioner define the provisioner name and parameters. You have to define what parameters required for the provisioner. Let me show you the example. AWS storage class Kubernetes. Maybe this might help. Mhm. Since we can try this, I'm just showing you. When we come to cloud, there is a topic called EKS. When Kubernetes in AWS, then we'll discuss all these things. Don't worry. But for now, theoretical part, not this. Where is the storage class? He's just like saying example. See, until here we have seen just now dynamic provisioning using AWS. Let's say this is the storage class. Some name provisioner C EFS dot CSI AWS dot com. There will be a provisioner name. Obviously, we can get by Google it. And these are the parameters required for the provisioner. So there will be ID, there will be permissions. I mean, so like this, you have to pass to the provisioner. And what happens is once you create a storage class, it will be created like this. You will get a CSV storage class. Now, how to use this storage class? How to use this is you don't need to create PV now because I told you right. Dynamically provisioning. Dynamically provisioning means you don't need to create a PVC. So you just need to create a storage class and you need to create a persistent volume claim with that storage class name. See, with that storage class name. Now automatically when you obviously you use this PVC in a pod. Now what happens? The PV will be automatically created. So you don't need to create a PV here with a specific size and everything. So you just create a storage class with the type, provisioner type and everything, and create a PVC with defining the storage class name, whatever the storage class name. Observe here. See, same thing. Now this will automatically create a PV, and once the size is full, it will automatically increase it. So no need to manually create the PV and increase the size like this. It will automatically create. But since we are using static, we have to create a manual PV, add the storage. If the size is full, increase the storage and apply the manifest file again, use it. So that's the difference between static provisioning and dynamic provisioning. So in dynamic provisioning, we use storage class PVs used to create PVs automatically using storage class. So we have to define few parameters. So what here, how it will create is PVC will, we have to use the PVC. That PVC will be created, PV automatically. You got it? What is storage class? And of course, this storage class is linked to dynamic provisioning. So is it clear? Any doubts so far?
No.
not
Yeah,
mount.
right. This storage class we can use for manual also. I mean here also. Simply what we do is, where is the syntax? Yeah, the storage class, we can remove all of these things. Simply just define the storage class, normal storage class, and we can able to use this. And the storage class can be used, in our normal. Like, let me create a storage class. Copy this, or let's Google it first. So, sorry, storage class normal. Yeah, normal. ML example again. Why to go to so many things? This is AWS again. See, for provisioner. Without provisioner, we have to use. Of course, PVC will create. If you observe, no PV because PV will be automatically created. I forgot the syntax. Yeah, like this. Let me remember. Um, yeah, let's write it. So simple. Let's write the API version. API version. This will be like storage.kts.io/v1 kind storage class metadata name something test. Yes, see something. So here what we have to define is, since it's a normal, no AWS commit, sorry, no cloud provisioner, we have to define uh, just the type as a normal, or let's say the provisioner as a normal. So, or you can simply give anything, any, let's say test, anything. So based on that, we can able to use this in our PV or in our PV and PVC. So as you someone asked right earlier, what if there are multiple access modes? The same thing, how do PV will get tracked? But now since you create a storage class, you define the storage class name, and the storage class name will be unique, for every application. They don't use the same thing. So they'll simply differentiate based on the storage class. So is it clear? I don't remember the syntax. Let me just see and hope I should find not here. Storage class, let's see. It's already here. See AWS, blah, 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 blah. Default storage class. See, these many types are there. Provisioners. So these many types of volumes you can have it, even FS also. Cloud things are there, but not. Say Kubernetes volume, vSphere volumes.
So in real time scenario, we will use storage
Sorry?
classes only, right? Or so in real time scenario, what we will prefer? So storage class or else PV with local
It
storage.
depends on your requirement. Let's say I have cloud volumes. My cluster is in cloud. I want to, use the cloud storage. At that time, you use the define the storage class like this because you can't create the PV manually. So you have to use the storage class only to create it manually. Sorry, automatically. That's when you use storage class. Let's say you are in normal bare metal clusters. I mean on-prem machines or physical machines. There you can't provision the storage automatically, right? You have to do it manually only. That's not possible in on-prem to scale the storage automatically. So at the time, without storage class, simply manual static creation of PVT. This is mostly useful for cloud storage class, and obviously, majority of the clusters will use in cloud as of today. So definitely we'll be using the storage class. Don't worry about skipping the storage class now. We have AWS start. We haven't started yet. Once it's started, storage class will come again. So don't worry. So is it clear so far in a PV, So do practice, watch a video, not just this one, any other video, so it will be fine,
Yes.
no issues. You have to understand the concept, that's it. So is it clear so far? How to create a PV,
Yeah,
how
bro.
to create a
Yes.
PVC, and how to use it, and what are those? What are PV, PVC, and what is storage class? What is the use of that, and why we use storage class, obviously. So is it clear? So
Yeah,
do
bro.
practice, and of course, I forgot to tell, tomorrow is weekdays, Monday, I mean. So our class will be on 7 a.m. regular timing. So on weekends, 7 p.m. On weekdays, 7 a.m. So do remember this. It's if something is changed, I'll let you know. Okay? Tomorrow, same time. Morning, I mean 7 a.m. Sorry. All
Okay.
right then. So bye.
And
Okay.
Bye all. Do practice. We'll meet tomorrow 7 a.m. Bye. Bye.
okay. And in yesterday we only covered horizontal pod autoscaler. So vertical
Vertical
pod autoscaler something
does
have.
not work by default. It cannot increase. That's why I haven't told that. Because majority will be using the HPA only. VPA we know we don't be using it because it's not possible. That's why.
Okay.
If I require, I'll mention it. Okay.
Hmm.
So yeah. So yeah. Any other doubts? I mean, so far, sorry, I forgot to ask. Any other doubts? If practice, obviously, you'll get the doubts.
Sure.
So yeah. Bye then. Bye.